Hello everybody, let me show you a quick proof of the so-called gluing lemma. Assume that you have a topological space X, which is a union of finitely many closed subsets Xi, and assume that you have continuous maps Fi, which maps the Xi to a topological space Y. And further, suppose that these maps are the same on the intersections. This means that if you intersect xi with xj, then fi should be the same as fj on this intersection. And if all of this is true, you have the following statement, which is the gluing lemma. There exists a function f, which is just fi when restricted to xi for each I, and which is continuous on all of x. So it is clear how f is defined pointwise, meaning it is just fi on the xi, and since the xi cover big X, f is defined everywhere. So the only thing we need to prove is that f is continuous on all of x. And to prove that a map is continuous, it is enough to prove that the pre-images of closed sets are closed. So suppose that C is a closed subset of Y, and we're going to look at the pre-image of C under the map F. The pre-image of C under the map F can be written as the pre-image of C under the map F intersected with the union of the xi, because remember this is just x, so we have done nothing. But this intersection can also be written as the union of the intersections of the pre-image of C under the map F intersected with xi, and this intersection of the pre-image with xi is nothing but the pre-image of the map of the set C under the map Fi, because restricted to xi, f is nothing but fi by definition. So we have that the pre-image of C under the map F is a finite union of pre-images of the set C of maps Fi, and these maps Fi are assumed to be continuous on xi. So we have that this union, which is the pre-image of C under the map F, is a finite union of closed sets and thus is closed itself. And this shows continuity, and this finishes the proof of our lemma. Thank you for watching. See you next time.